Hi, today I'm going to go over exponents in scientific notation, something that you need to know before taking on college algebra. So, exponents. Well, you should know exponents are telling us how many times we're multiplying a number by itself. So it'll take x to the power of 3, x times x times x, 3 times. Same with x to the power of 5. Multiplying x times itself 5 times. Now, what would happen if we multiplied x to the third times x to the fifth? Well, you'd get all of these. X times x times x times x times x times x. 1, 2, 3, 4, 5. 1, 2, 3. Yeah. 1, 2, 3, 4, 5. 1, 2, 3. Yeah, all of them. Wow. Or we would just be adding the exponents, right? Because we're not, we're not taking these and multiplying them by themselves. We're just multiplying these 3 times all these 5. So we get x to the 3 plus 5, or x to the 8th. Because there's 8 x's there. You see that? How we're just adding how many times we're multiplying this same number by itself. Now you can only do that if this number is the same as that number. We call that the base of the exponent. And this is obviously the exponent. But compare that. See, x cubed times x to the fifth, sometimes I call it cubed, same thing, x to the third. Compare that to 3x times 5x. Completely different situation. This isn't an exponent, this is a coefficient. So you actually multiply those together and you get 15. But you are multiplying these x's together, and those have an understood exponent of 1. See, everything has an exponent. So you'd actually have x to the 1 plus 1. So your answer is 15x squared. Try not to get those two confused. Completely different answer. All right, now, there's a lot more to exponents than just that. That's just the beginning. That was just multiplication. What if we took 3 over y and cubed it? Whoa. A fraction raised to the power of 3. Wow, okay. Well, what did we just learn? An exponent is taking whatever it is and multiplying by itself 3 times. So you just take this whole thing and multiply it by itself 3 times. You do the numerators first. 3 times 3 is 9 times 3, 27. Y times y times y. Y to the third. Some people like to think of it as 3 cubed over y cubed. You're just kind of moving that's not really what it is, because let's say you get something like y plus 1 cubed. That is much different. That is something you'll definitely be going over in college algebra, but not today. I just want to make sure you understand the concept right now in this video. But that would not be y cubed plus 1 cubed. No. Just FYI. Anyway, so that's the power of a fraction. Now, what if we wanted to multiply that by another fraction? Well, we just did this. Order of operations, parentheses first. There's two different sets of parentheses. Let's do this one first, exponents first. 27 over y to the third. Now, can we simplify this a little bit? Yes, we can. That's our next rule. It's called the quotient rule, actually. Quotient being a division problem. Since 2y is being divided by y squared, we're actually kind of, it's kind of similar to what we just did. You know how we added the exponents together? This time with division, we're actually subtracting them. This has an understood 1 by it, right? 1 for an exponent. 1 minus 2 y to the negative 1. What y to the negative 1? What is that? Now, that is another very, very important thing to know. Any negative exponent can also be written as the reciprocal with a positive exponent. So now it's just a positive 1. Now, as you learn this, you'll start to think of this as just canceling out. See, there's a y up here, and it's getting divided by 2 y's down here, y times y. So we would just kind of cross this out, and that y would be gone. And cross that out, and that would become a 1. So we're still left with the 2 over y. If I moved that back up to the top, it would be y to the negative 1. If I move this up to the top, that would be y to the negative 3. Why don't we do that? Just to have fun. Multiplied by 2y to the negative 1. If you don't like fractions, I mean, you could always do that with the exponents. Okay, now we have got to multiply these together to simplify it, right? 27 times 2? I don't know. 7 times 2, 14. 2 times 2 is 4 plus 1 is 5. 54, yeah, that sounds right. 54. Y to the negative 3 times y to the negative 1 negative 3 minus 1. We're adding them together, so we're actually adding a negative 1, but adding the opposite is the same as subtracting, so that's why I just put minus 1. so as not to confuse it with the division part of it. You know what I mean? (54y to the negative 4). And if your teacher doesn't like negative exponents, you can always say that's your answer. Make sense? If it's too much for you to remember that, you know, when it's division that you subtract them, then you can always just remember this part. And just, you can go back and forth. Move this back up to the top. Make that exponent negative and add them together because it's always adding. But since it's negative now, then it becomes subtracting anyways. So you'll still get the right answer. All right. Let's do something a little bit crazier. So we've done multiplying, we've done dividing. What if you have something that's raised to the power already, and then you raise that to another power? Okay, let's see, 2t squared, what? All raised to the third power over t times t cubed to the fifth power over 4t to the 10th. Okay, we're going to use all of our knowledge so far, plus we're going to learn something. Parentheses around this, so this whole thing is getting raised to the power of 3. So what happens? We get 2t squared times 2t squared times 2t squared again. So what do? We have to add all these together. 2 plus 2 plus 2, which is 6, actually. Well, I thought we just added them and we get 2 plus 3 is 5. No, this is raising it to the power. This is multiplication, and we add them together. But this is why we're just going to multiply them together. 2 times 3 is 6. It's the same as adding all these together. No matter what the exponent is down here, no matter what that exponent is up there, we'll get the right answer. Does that make sense? 2 plus 2 plus 2 is 6. So t to the 6th. 2 times 2 times 2 is 8. So 2 times 2 is 4 times 2 is 8. Yeah. All right, now what about this one? T to the third raised to the fifth power. Wow, that's, I don't want to write t to the third times 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 t to the third. There we go. 1, 2, 3, 4, 5. Yeah, that's all 5 of them. We're multiplying this by itself 5 times. See? And then you could write all of those because we're multiplying this by itself 3 times, this by itself 3 times. So that's just a whole lot of t's. But we could just multiply these together. 3 times 5 is what, 15? And we'll leave that the same for now. 4t to the 10th. Excellent, right? Oh, man. Wait a minute. Okay, now we got to multiply these together. Oof. Well, that's just 15 plus 6. That's not bad. But I wonder if there's an easier thing we could do here. Multiplication and division are kind of the same in the order of operation. So you can do division first if you want. T to the 15th divided by t to the 10th, same as t to the 15 minus 10, right? And same thing here, t to the 6th divided by t to the 6 minus 1, right? So 8, t to the 6 minus 1 times t to the 15 minus 10 over 4. All right, I'm running out of room on my whiteboard here. So I'm just going to rewrite this again up here. 8 t to the 6 minus 1 times t to the 15 minus 10 over 4. Okay. Not too bad. My 5 doesn't look very good. That's okay. T to the 6 minus 1, that's 8 t to the 5th. T to the 15 minus 10 is t to the 5. Again with the 5. Over 4. That's a little easier. T to the 5th times t to the 5th. Now, 8 times, then understood 1 in front of it for that coefficient, right? So 8 times 1 is just 8. T to the 5th times t to the 5th is actually t to the 5 plus 5, which is t to the 10, right? Forgive me for skipping a step there. Okay, are we done yet? No, that's just t's are done. What about 8 and 4? 8 divided by 4 is what? 2. There's your answer. Now, that was a pretty tough one. Let's try one even tougher. Because we want to think smart about these things. We don't want to make things too difficult for ourselves, which is why mathematicians discovered all these neat rules to get around difficult things. Okay, can you read that? 21r cubed squared over 21 times r cubed squared. Oh. Like, geez, Joe, why would you ever give us 21 squared? That's 21 times 21. Who wants to do that? No. Hand me my calculator, please. What if I told you don't even have to do that? You could just do this in your head. Take everything you learned so far. Just focus on that part first. We have 21 squared, right? r cubed squared 3 times 2, r to the 6th. Okay. Now the bottom. The 21 here is not being squared. The parentheses are around the r cubed. So it's just 21 r cubed squared, which is r to the 6th. Okay. Well, that doesn't look so bad. And just like that, r to the 6th over r to the 6th, you take any number, divide it by itself, you get 1. So that just canceled out. That becomes 1. 1 over 1. 21 times itself divided by itself, that cancels out too. Because this has an exponent too. Because 21 is a number just like r or x or whatever variable we use. So you can actually do 21 to the power of 2 minus 1, and you just get 21. Oh, did I say that one was hard? Yeah, it's not really hard. I lied. All right, well, that's the exponent part of our lesson. Now we get to scientific notation, which is just more exponents, unfortunately. But I call it scientific notation because it's mostly used in science with extra large numbers and extra small numbers. So what I did is I just Googled the mass of the Earth, right? And they give me the answer in kilograms. But they don't give me an answer with a bunch of commas or anything. They don't say it's such and such gazillion. They give me this 5.9722, most definitely rounded off, times 10 to the 24 kilograms. What? And I like the kilogram answer because that's what we use in science class. So if you're hoping for pounds, you're SOL, man. So yeah, why would they give us that? What's with all the multiplication, the 10, and the exponent? What the? It's because this number is so huge. Let's just write it all out here. 59722. Okay. Now, this is what that exponent means. When you multiply something by 10, you're actually just moving this decimal over, right? So let's multiply this by 10 to the 24th, which means we're multiplying it by 10 24 times. So we're going to move this decimal over 24 spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And that's where the decimal is. Put a comma after every 3 zeros. That is the mass of the Earth in kilograms. Holy crap. It's the thousands, right? This is millions, trillions, billions. What comes after billion? No. Millions, billions, trillions, quadrillions. Yes. And what's after that? Quintillions? What? Sextillions? That sounds made up. Septillions. Okay, so they wouldn't just say it's almost 6 septillions kilograms, they give you this number. Because it really is a pain in the butt to write that all out every single time you have to deal with the mass of the Earth in science class, especially in physics class. You gotta use this a lot to calculate a bunch of gravity problems too, because the mass of the Earth is what gives us gravity, keeps us on the ground. Now, that is why we use scientific notation and why it's mostly used in science. That's for the big numbers. What about the small numbers? Because there are some seriously small things in this world too. Radius of an atom of hydrogen. 5.3 times 10 to the negative 8 millimeters? What? Do you know how wide a millimeter is? Take a paper clip, turn it on its side, so just the tiniest thing, and that's how wide a millimeter is, okay? But what is this? Now they're using a negative exponent. I'm like, well, doesn't that mean that's like 1 over 10 to the 8th? Oh, 18. Yeah, it is 1 over 10 to the 8th. We're actually dividing by 10 to the 8th when they say that. That's how small it is. It's, what is that? 8 zeros? That's 10 millionth of a millimeter. Take that little paper clip and slice it into 10 million pieces, equal size pieces, and that's how small you get. Let's write this out now too in decimal form. Start with a 0 in the ones place, and then the exponent is telling you how many times we've multiplied by 10, or in this case divided by 10. 1, 2, 3, 4, 5, 6, 7, 8. Oh, wait a minute. We forget. You go over 1 place, and then you add. So it's 1, 2, 3, 4, 5, 6, 7, 8. So there would be 7 zeros. 1, 2, 3, 4, 7. Yes. 1, 2, 3, 4, 5, 6, 7, 8. There you go. 0.000000053 millimeters. That is the radius of an atom of hydrogen. Very, very, very small. Now they've come up with different names for smaller numbers. I mean, millimeters are already really small. And if you Google it, some of them might say it's 0.053 nanometers or something or other, but yeah, that's why we use scientific notation, so that we don't have to memorize all those different measurements. We can just, okay, we know what a millimeter is. Let's just compare it to that. Okay. Now, why are we learning all this? Well, sometimes we have to do math with them. And sometimes it would be really nice if we didn't have to input that number into our calculators all the time. By the way, the key on your calculator for exponents or scientific notation, really, not exponents, is the big capital E. So if you put, 127 E E2, oh, wrote that wrong. That's actually 127 times 10 to the 2 power, or just 12,700. Take that decimal point, move it over twice. See, it's not really a very good scientific notation because the decimal should be over here. But you get the idea. All right, what if we were given some crazy small numbers and big numbers, 8.14 times 10 to the negative 7, and they wanted us to multiply that by, 6.5 times 10 to the what? Are you kidding me? Times 10 to the 10? Oh. We have to use a calculator now? Not yet. We're actually saying that because this is multiplication and this is multiplication, we can actually separate these out. 8.14 times 6.5 multiply 10 to the negative 7 times 10 to the 10th. Oh. Now let me grab my calculator here. It's pretty much always going to have to use a calculator for these problems. Let's just do this part though. 8.14 times 6.5. 52.91, that sounds right. What about this part here? Times 10 to the what? Well, we've been doing this whole video. Same base, right? So we can just add those exponents together. Negative 7 plus 10. Negative 7 plus 10, also known as 10 minus 7, just 3. 52.91 times 10 to the third power. And your teacher might say, leave your answer in scientific notation. You can move that decimal over a little bit because they like it if the decimal is right after the first number. Just like how they have it up here, right? So if you move that decimal over, this goes up 1. If you moved it the other way, it would go down. See how that works? So yeah, there's scientific notation and exponents. Please like and subscribe, and if you don't subscribe, you're probably going to get more videos like this anyways, because YouTube has an algorithm that suggests things like that. Thanks for watching.